My name is Oleg Selajev. I'm connecting to you from Tartu, Estonia. So it's a lovely summer here. And I work as a developer advocate for Testcontainers, which is a wonderful, wonderful open source project that helps us do integration tests better. So this is a short presentation. We're going to run through some basic theoretical info on what do we understand when we talk about integration tests, how test containers can help, and see a little demo. And then I hope you have some questions where we can go a little bit deeper into more advanced usage patterns of this thing, right? And why do we talk about this in general? Because I personally strongly believe that not test containers, tests are one thing that improves quality of software that we write. Right? We sort of, as an industry, we do know that if we create good tests, it's easier to maintain software, it's easier to evolve software. So hopefully, eventually, right? Not right now, not immediately, but eventually, hopefully, we're gonna write more tests, we're gonna write better tests, we're gonna write better software, and through that, live in a better world, which is a great ambitious goal. I hear you. I hear you. Right. So we're going to talk about test containers, which is a collection of libraries. It's available in different languages. It started on the Java side, something like 8 years ago. We're going to talk a little bit more about that, but this presentation will be focused on test containers. Right. How do we test our software? How do we test our applications? I'm pretty sure that most developers, when we think about tests or organization of tests, have something like this picture in their mind. So we are talking about testing pyramid. We have different types of tests. We have a lot of unit tests that kind of check the correctness and verify behavior of individual components in our applications. We have fewer uh, more sophisticated integration tests, which test the combination of the components within our systems. And we have the end-to-end tests, which are even more complex. They usually run in the environment similar to the production environment. So the whole production system, or a clone of the whole production system, is spin up, and then you can test them either automatically or manually. And those are hard to maintain. They usually test just a few scenarios, like happy path. Uh, and this is what usually developers think about tests and how to organize them. Unfortunately, in the recent years, we started writing software a little bit differently. Not all the teams, of course, but very often we started migrating to different architectures. We started implementing microservices. We started building systems where individual components are not part of the same process, but very often this is a separate processes running either locally or like in the cloud or anywhere. And the business logic of individual components very often is sort of reduced to a smaller functionality, and the system, the behavior of the system is sort of encoded in the actual deployment. So that change made us, as the industry, as the community, realize that unit tests are not always the answer. Unit tests are helpful, unit tests are healthy, and they protect you from certain kind of issues, certain kinds of bugs. But in the microservices world, this is not as a pronounced problem as it was maybe before. Our IDEs got better, our tooling got better, um, our programming languages got better. So very many things now just are not an issue for the particular things. At the same time, the importance of integration tests, where we would like to verify that our component, our application works with the technologies that it needs to work with in production, grew in importance. Because if our individual microservice or individual app needs to talk to a few data stores, send metrics or send logs to Elasticsearch, and then send messages to Kafka, work with the database, I don't know, interact with some other services and APIs, then those things are much more important to test than the particular combination of whether we I don't know, parse strings correctly or implement the business logic of picking the most appropriate reservation out of a list of reservations. So many teams individually started coming out with how they re-implemented the testing, and how they reimagined that testing pyramid. One of those was this team at Spotify, who are incidentally a very large user of test containers, and recently even announced that, and supported test containers projects with their open source grants. Uh, that's a minor point. So what they did back then in that blog post that I'm referring here, they said that they started reorganizing their tests to have fewer tests that test implementation details of the individual component, and more higher level tests, integration tests that check whether the application that they were writing work correctly with the technologies around them. And through those tests, they also actually cover the code paths necessary for the lower level behavior verification. If your application correctly works with on the certain data inputs and produces the correct data outputs, in the higher level tests, then you do actually know that it behaves correctly for the lower level unit test details. And they also still have some integrated tests, but there are fewer in numbers, and they're actually still run in the sort of production-like environments, clone production-like environments. But the important part is the bulk of the tests can be integration tests. And this allows the teams to achieve high levels of confidence in their test suite, and high level of confidence is that they're going to release working applications. There are other teams came up with different shapes here. There were like chalices and mushrooms and whatnot, but they're all kind of sort of agree on one thing, that the importance of unit tests, of those smaller individual tests, are less pronounced in the current architectures and how we write software. So that makes integration tests are much more important. What do we mean by the integration tests? This is not an old concept, right? We want to have our system that consists of different components, and we want to isolate the components that are needed for verifying the code, the behavior of the code that we're working on right now. So if we're building this red block there on the left, and it depends on a bunch of services, we would like to limit the environment around it for the tests to one level. We cannot go much deeper, even though we would like to maybe sometimes, but we shouldn't, because then we don't know how much of the environment we need to spin up, and that will make tests that are fragile, hard to maintain, and slow in running, because they need to spin up the whole fleet of microservices potentially. So we want to limit to one level. If those dependencies, service dependencies that we require to run our application with, if they are off-the-shelf stock software, databases, Kafka, message broker, other message brokers, cloud technologies, and so on, we can spin up the true doubles in some way. If those are the APIs that either our teams maintain or it's a third-party API, we can create mocks on the service level, and then we can verify the behavior of those mocks using contract tests. That means that whenever we run those integration tests and they fail, like, it's only the whole responsibility is on our team, the whole responsibility on the code that we're working on. So it only can fail if that red block we're working on does something incorrectly. And this is exactly what we want from the tests. We want the tests to highlight the issues in our code and never fail because somebody else's thing does the wrong thing, which is great. So the takeaway here, we're going to limit the environment to one level of service dependencies, and we're going to run it. How are we going to run it? Pretty simple, right? We're gonna stand on the shoulders of giants. We're going to use Docker, which is a great platform for running things. There are a number of advantages of using Docker. First, it's almost universally available. Uh, it's very, very popular. It covers the most operating systems that our development environments and CI environments run, and it's great for isolating those service dependencies that we want to manage. Right? Docker provides us with the unified API to isolate the process that we want, to configure it using the file system or network access, to impose the memory limits, to expose particular configuration from within the containers that we are running. And in general, Docker is a very, very nice abstraction for running other people's applications. It's also a great abstraction for allowing other people to run our applications, but we are interested in mostly taking other people's software and running them locally in our tests. However, running other people's software in tests specifically, using the normal Docker command line is not particularly convenient. Why is that? Because while it allows you to run things, it lacks certain flexibility for configuration. It lacks certain flexibility in how you interact with the running container. And it imposes the manual overhead on running, starting things, cleaning up things. So it's a like sort of a separate platform, and you need to cook it yourself. That's where Testcontainers comes in. Testcontainers Java was created 7 years ago, which is a lot of time, given that Docker was actually created just a year earlier. It's an open source project. It's available on GitHub. There are plenty of contributors. I think we are currently at more than 300, which is quite a lot. And it, like what Testcontainers Java does, it integrates with the Docker using the API. And on the other hand, it integrates with your application frameworks and your testing libraries like JUnit or Spock. Well, frameworks, of course, Spring, Micronaut is covered, Quarkus is covered, and it's very, very easy. It provides you with the flexible API so you can integrate your custom solutions if you want to. So it is a layer that sits in between, and what it does, it allows you to manage your services running in Docker in a more flexible way. Besides just running the services, what it does, it is specifically created for the tests, for integration test needs. So it runs system checks to verify that you actually can run things within your Docker environment, that there is a Docker host, Docker daemon that your test can connect to, that the files are mountable, that the configuration is sufficient, that your test will not fail for Docker reasons. Right? Besides the checks, it does the extensive cleanup. So while you're running things, you can, even a single test, you can spin up a number of containers and they will be running. And then even if your tests crash or fail or exit sufficient, like normally, right, Testcontainers will clean up all the Docker containers that we're running. So it will create this reliable environment where you can rerun the tests again and again and again, which is very important, because if there is something lingering after some test, then you never are sure if a failure of a test is actually an artifact of your test setup, or this is something wrong with your application. So by ensuring the cleanup, Testcontainers make sure that failures are actually the responsibility of the code. Well, obviously not in the 100% cases, but like Testcontainers does a very good job at trying to prevent all those irregular things that mess with the reliability of your tests. So there is cleanup. Besides that, there are like Testcontainers libraries go extra mile for certain things that are specifically we know interfere with people running efficient integration tests. For example, when you expose things from the container, if you run different containers that want to get the same hosts, same ports, then on your host, that resource is limited. You can only open one port with a given number on your host machine. And if you run multiple containers, that will be an issue. So Testcontainers by default ensures that the ports are randomized on the host side and then exposes the API to get that information. It exposes API and has the API has the means to configure the containers very efficiently and applications in containers when they're already started. So it allows you to run data-driven tests to avoid all kinds of hard-coded data scenarios. Also, the whole Testcontainers idea is that there is a certain level of isolation between the services that you run in the Docker. So you can easily run your tests in parallel if you want to, which alleviates the problem of having slower tests. which some people feel very important. I also feel it's very important because there is only a certain limit of time for how much you want to wait for your CI environment to run uh, before it starts kind of sort of impacting your delivery pipeline. So parallelization is very important, and test containers kind of handles those issues for you and encourages you to make like reasonable choices when you're doing those, when you're writing your tests. And as I said, it's not just Java. So like the libraries are available in other languages as well. Those are mostly contributed by the community members. So somebody would be like, oh, test containers Java, such an amazing project. I'm now working in Go or I'm working in .NET. Like I would love to use something similar. And so people created those libraries in other languages. They are all at a little bit different level of compatibility with the Java version or functionality wise, but eventually they will get, well, first of all, they are all usable, duh. But second, we would love to contribute and get them all to the same level of technical excellence as Test Containers Java. By we, I of course mean Atomic Jar, where I work currently, and Atomic Jar is the company created by the maintainers of the Test Containers Java library, and we are working on improving the experience of running integration tests for everyone. So other languages also have test containers. So if you have teams at your company uh, who use something else, you can be like, oh, I went on this Cloud Builders Conf and I heard this amazing test containers thing. Maybe you should look at Test Containers Go or Test Containers Node. It's not on the screenshot, but there is Node version as well. Yeah, probably some else, right? .NET is also there, right? So with all that out of the question, let's look at the small demo of application, what test containers can do, and I think it might be interesting. Right, here's my ID. You can see this is IntelliJ IDEA. This is a sample Spring Boot application. It's very simple. What it works with, it works with ratings for the conferences. So the data model is very simple. It's just the session ID, the string, and the rating, which is a number. But the importance of this application, why is it a cool application, is because it works with different services that it requires for the application to run. So it uses Kafka to store ratings, and it does that through Kafka template. It uses the Redis key value store to storing something else. The particular details of the business logic here are not that important, but it does use Redis, and it also uses the JDBC normal relational database to store the sessions. So this application is fairly an overkill for the demo, but it uses a bunch of technologies that we need to run the tests. I also have the test here. I have the tests and I have a good selection of the tests. So we have the demo application test and we autowire the talks repository. We verify that the context can load and that the certain test data exists. We want to verify that the actuator health endpoint returns to 100. Our application starts normally. We verify also the normal behavior of the application. We take uh, we use the rest assured library, which is a very cool library for making the HTTP queries, specifically in tests. And we send new ratings to the ratings endpoint and verify that the behavior that we expect actually works. So we send things and then we await for the ratings to progress through the application. And then, well, we expect the rating to appear on the other side where we get the ratings for the particular talk. And then we do that again for a number of things. And being responsible developers, we also even have the sort of the negative use case tests where we try to access ratings for the non-existing talk and receive 244. Right, so a few libraries here. So rest assured is a great library. Even if you don't use test containers, this is the great library to be aware of. And another one is the awaitility library, which works with all things asynchronous We use that extensively in test containers to wait for certain conditions, for example, the container starting or anything like that. And you can use that in your tests. It's really, really great. And it's very easy to use in combination with rest assured. So here, for example, we await until the ratings will be there, which is very easy. And then this way we can avoid hard coding the timeouts, and our tests are fast and nice and easy to work with. Right, so those are the tests. I can run them. I can show them that those tests actually do not run because the environment that our application requires, the database, Kafka, Redis, is not there. And I will also show you, while it will wait a second to fail, I will also show you the, what's that? I will show you the superclass, right, with the boilerplate. This is very simple. There is nothing test container specific. We set up the rest assured thing. We set up the application running on the random port because we are all about that parallelization. And this is just the base class where we have this. So now let's create the environment here to run our integration test. And I want to show you how easy it is, right? What I need to do, where's my POM? In my POM, I need to find the test containers and add the test containers dependencies. There are a bunch of modules for all kind of technologies. So you can just get the artifacts and get the abstractions to work with Kafka or Postgres or Kubernetes or Mongo or MariaDB or Cassandra or Elasticsearch. I don't know why I added so many here. We don't actually need all of those, but it's a good example. And we bring in the JUnit integration if you want to manage the lifecycle of our containers through that. Now, with the dependencies here, what we can do the very simple thing. We can just say static and say the main API is the generic container. We're going to say Redis, and this is our new generic container. And we're going to say this is Redis, 6 Alpine is a good thing. Now, generic container is the abstraction that allows you to manage the dependencies, service dependencies that you want. And it gives you all the configuration that you want to do with Docker, and it allows it to use from your IDE. You can configure networks and accesses and resources that you want to copy into the container, out of the container environment, run commands, all of that. We're going to expose the port. What's the exposed port? I think the Redis exposes the 379. You can see that we don't say what is the host port here because it will be random. Now, all the configuration is here, and also the lifecycle methods are here. So we can start it, we can stop it, but this is as easy as it needs to be to run a Redis instance in a Docker container using test containers. Now we're gonna use the dynamic property source here, which is a method takes the dynamic property registry. And what we're going to use here, this method for, this is a Spring Boot abstraction, and we're going to use the registry. First, we're going to start Redis, right? And then we're going to say registry at Spring Redis host. And this is, I think it's a Lambda. No, it's a what? Redis host. Right. So we're gonna take get first map port. We're gonna configure our application to run with this Redis in mind. So when our application will need to access Redis, it will actually go and access this Redis thing. It's going to be even simpler with Kafka because we can say Kafka container, and this is the abstraction. Somebody created the abstraction how to run Kafka in Docker, and this is very, very simple. With say just new Kafka container, and say Confluent Inc. CP Kafka. What's the version of that? 546. 546. Right. So this is all that we need. In parse. This is all we need to create the Kafka container. We're gonna start it as well. So we're gonna say startables, deep start, Redis, Kafka, start them in parallel, and we don't need this one. Kafka container, and we need to configure things. Registry at Spring Kafka Bootstrap servers. I don't know how to run Kafka in the container, but I can definitely know that whoever created that abstractions knew what the Bootstrap servers are and how to get the URL for that. This is a certain thing that Kafka does, right? So this is it. I can also do the Postgres containers the same way. And I will actually, shall I will not do that. I will use a certain thing that is the JDBC URL here. Wait, JDBC support for relational databases. This is one of the simplest thing. We can take the JDBC URL and add the TC prefix there. So I can just do this Spring data source URL equals, and I will just do what Postgres 14. I know that 14 Alpine is decent, right? The database name is not relevant. So this is all that I need to have to create the Postgres container within the Spring application. So that just the DBC driver will take it over, will run it, and will create Postgres for me and manage the lifecycle and configuration of all of that. So with all that, I think now if I run this thing, my test will pass. How are we doing on time? Do you have a few more minutes?
I think yes, we have more, approximately 8 minutes. It's your time, so you can continue.
Perfect. We have 8 minutes, so we're gonna now supercharge this setup. So this is very basic scenario, right? So what we need to do is here, we create Redis, we create Kafka, we create our Postgres database. We start running the test. You can see that Testcontainers now downloads and pulls those images. I'm not using a local Docker host here. I'm using Testcontainers Cloud Client. So my Docker sits somewhere in the cloud. And because it's a new environment now, for the first time, I need to pull the images. It's going to be fairly fast. And then we're going to run the tests, which are going to be even faster. Of course, the second time I'm running those tests, it will be even faster because it will use the local cache of the things. And now we are proceeding to running the tests. Right? We test the ratings, we initialize our application, and we run our everything here. Now, it's not just like you can see that we run the things, and we also can we do this? Let me show. But if I just do this, docker ps, right, we have no container images anymore here. I'm going to run this thing again. So we run the tests just for you to show. And then if I do this smaller thing, you can see, can you see? We are creating the containers. We are creating the containers, and the containers are being run. But then when the tests will pass, the containers will be cleaned up. We're actually using a fairly cool component there called Rook, which is also a container, and it is configured to clean up the containers even if my tests crash, and then even if they crash and you cannot run them. Right. So the tests are passing. You can see that tests that actually just don't do any waiting for the components on the application logic, they pass in milliseconds. The test that does waiting on the ratings to propagate through the whole thing takes a few seconds, but they are fairly short-lived anyhow. And you can see that Testcontainers remove all the things here, right? So this is what we have here. And this is our database. I want to show you the configuring things, because that is probably the most important thing that I can do here, right? So I'm going to do the Postgres container. Postgres container, Postgres, and I will remove this thing, right? New Postgres container. And this could be, I think, the same thing, right? Postgres 14 Alpine. What I can do now, I will configure it. I will configure it for data initialization. So currently, my schema sits here, and my application initializes SQL by the Spring means. So if I change this to not do that, uh, I will just I can copy things, and this is a very useful thing. So I'm going to say I want my schema SQL, and I'm going to copy it to a particular directory, in my Docker image entry point. So I know that my Postgres image has the capacity to execute initialization scripts if they put in the correct directory. So I'm gonna put it exactly in there. So my schema SQL will end up in that directory, and then the Postgres database will initialize that by itself, which is a much more convenient way of doing this. And then of course, I need to configure thing, right? I need to start the thing, and I need to say that my Postgres is now here. Spring data. No, what was the thing? Spring data source URL, right? And this is the Postgres get JDBC URL, and then the username, get username, and then of course the password, and here is password. Now we're managing all our containers manually. We can still run all the tests. Actually, you know what? I'm not going to run all the tests. I'm going to just run the context test here, because I don't care about all the rest tests, right? So just stop this and just run context loads, because that's the one that works with the database. I know that I have this context load test that verifies that my SQL database is there, right? We can configure everything here, and the best part is all the configuration is at my fingertips. As a developer, I might not know about Docker or the particular details about Docker, but I do know how to use my IDE. I type dot, and my IDE tells me what it can do. I can build complex hierarchies with networks and the depend on chains. I can do any configuration. I can execute commands. Uh, I can override the command that is run for, like, when the Docker container starts. I can execute commands in container. I can get, well, anything you can do with Docker, you can use with Testcontainers, and you can run anything, not just the predefined modules. You can always use generic container and run whatever images you want. So on one hand, Testcontainers offers you reliability of your tests. And on the other hand, Testcontainers offers you this unit test look and feel, where it integrates with your application frameworks, where the whole configuration is in the code, so it will never kind of sort of detach with what your application is doing. And all in all, it runs fast. It you can specify the lifecycle of the containers as much as you want. It's a very, very flexible approach. So all in all, right, as I was saying, you can do much more than just create and start the containers. You can create custom waiting or startup strategies to ensure that your, I don't know, your database is there and ready to accept things. Not just the container is started. You can create the images on the fly with Docker files, or with saying that, oh, from the strings of the Docker files, and you can set up the limits, you can access logs, you can run commands. The best part is there is no YAML. You don't need to mess with YAML, and it's all encoded in the class hierarchies and the API from your ID, which is pretty amazing. Even more, if we talk about local development, not just about running integration tests, Testcontainers API, there is nothing test specific, right? Testcontainers API is fully available to you whenever. So if you have your Docker environment, if you have your Docker daemon, you can spin up the versions of those service dependencies that you need, your database, your Kafka, for your local development. In Quarkus, that is known as dev services. In Micronaut, in the recent release, they introduced Micronaut test resources. For the Spring Boot, currently, there's an issue that you can thumbs up if you want to create a sort of a local development environment using Testcontainers API for like based on your application needs, and they simplify working with projects much compared to manually managing the environment. You clone the project, you run the project, it runs, you implement your fixes or changes, and then you implement tests, which are very easy to do, and the environment is there for your tests automatically. So it's all very flexible, very nice. I think relying on those higher level integration tests made many teams, we hear that many teams were much more uh, confident in their tests and much more productive in actually implementing the functionality, knowing that the test suite has their back. So all in all, what I wanted to say is that very often technologies are sort of the complex problems usually have complex solutions. So having a hard problem and replacing it with a hard solution is not particularly beneficial. Or replacing an easy problem with an easy solution, either not very beneficial because you could do that already. So I think Testcontainers hits a very sweet spot between giving you the absolutely trivial, mind-blowingly simple ways to create those development and those integration test ephemeral environments that you need, but also has the flexibility to go all the way to 11. You can do network topologies, you can introduce chaos engineering practices, you can switch up network access and see how your application behaves when Kafka is not available. It, it's great. It's great. And what it gives you control over the situation as a developer, which is, I think, very great. Right. If you don't have Docker, or if you don't have a particular version of Docker or vendor of a Docker, Testcontainers uses the Docker API, so it works with any compatible Docker environment. Last year, we ran some tests, and we ran actually the Testcontainers Java test suite by itself. Of course, it passed on Docker Desktop. It also passed on the Docker machine, which was the previous version of how you can run Docker. It passed on Minikube, which is a local Kubernetes environment that exposes Docker API, and it was fairly straightforward to configure. It didn't work at the time on Podman, specifically on Windows and Mac OS. There were some issues that we hope will be resolved. But what we wanted to discover, and which is sort of we supported that with evidence there, is that compatible environments allow you to run Testcontainers based tests nicely without extra effort for configuration and whatnot.
Okay,
Internally
Oleg,
at the,
thank you very much for your speech. It was really interesting and very useful regarding test containers. I'm sure that our attendees today will, I think, in the evening or at the night, maybe start to try test containers on their own application in projects or in pet projects. And we have really a few questions, and let's go to them and answer because people are really interested. Uh,
very good,
okay,
excellent.
good. One of them is how can we provide testing of different versions of third-party services like databases? For instance, the same test but different versions of PostgreSQL.
Right. This is like you. That's a good question, and since actually the configuring what service you're running is in your code, you can do, however, one way I would maybe look at that, I would try to maybe parameterize my tests. So with the JUnify parameterization, for example, I can have my versions or versions of the Docker containers, Docker images that I want to run against, I don't know, in a file or in a string. And then I would run the same tests with just the different sort of inputs, right? The Docker image name, the version of the database that you want to run, is an input to your test. So that is one simple way. I know another way you can just hard code that. There was a recent blog post by Vlad Mihalcha, how he introduced test containers into his project, which is Hibernate types. So it's a sort of a library that simplifies working with some different types of Hibernate. And he needs obviously to ensure that that works for all reasonable databases, right? So he brings an example there, and I'm sure I can find the link, and we can share the link with the people in chat. He brings an example of how he did that and how he set it up to run tests against Oracle, Postgres, uh, MySQL, and I think something else. But in the same way, you can just replicate that setup, for example, and run it for two different versions of Postgres.
Okay, thank you, Oleg, for sharing your knowledges, your experience, and we're happy that you joined to us and support Ukraine. Thank you.
I'm very happy to do so. Thank you for having me. If you have more questions, find me online.
Good. Goodbye.
Thank you.
Okay, guys.